Chapter 5, Section 8 in the 7th grade workbook is entitled Direct Variation. What is direct variation? In direct variation, what we have here happening is that we have two values increasing at the exact same rate. For instance, if I tell you that it takes one worker to build 2 computers, and then I tell you it takes 2 workers to build 4 computers, well, in either case, every worker ends up building 2 computers. One worker builds 2 computers, 2 workers build 4 computers. If you divide that out, either way, it ends up being 2 computers per worker. Right, that's what a direct variation is. Right? It's going to show the same rate of growth for 2 different values here. So in this top part here, where they're asking me here is to show if this is direct variation, and if it is, to identify the constant of variation. Now this is actually a good follow-up from where we were yesterday, because in the terms of the equation, what you're going to be looking for is slope-intercept form, but the b value is equal to 0. Right? It's going to go through the x-axis and the y-axis, really, at the point 0. Really, it's the y-axis is the one we're concerned about, but it's really going through both at 0. It's going through the origin. So, for instance, if we look at the equation in number 4, not only is that in slope-intercept form, but we see that the y-intercept value is 0 there. All right? That means this graph is going to go through the y-axis at the value of 0. Well, that being the case, that means this one is direct variation. Again, anytime this b value equates to 0, your answer is going to be yes. Your constant of variation is that growth rate. So if it takes 1 worker to build 2 computers, 2 workers to build 4 computers, the growth rate is 2. All right? Everybody's getting 2 computers made there. All right? The constant of variation in this particular case is the only number that ends up being in the problem. So in this case, looking at this question, or the only one that counts here, because this really I could throw out, it doesn't mean anything. The only number that's here is 13. So the constant of variation, k, is 13. And again, that's expressing that growth rate. Now, if we look at a question like number 5 is a little bit trickier because it's not in slope-intercept form. We can make it in slope-intercept form, though. We can make it into slope-intercept form if I divide across by 4 here. When I divide across by 4, these 4's are going to cancel out and leave me y. And here I'll have 2 fourths x, which I could then write as, of course, if I reduce it, 1/2 x. Well, does that have a y-intercept value that's equivalent to 0? Yes, it does. All right, I could add on plus 0. It wouldn't change anything here, but it's going to go through the y-axis here at 0. So that means this one's another yes. Only number that gets left in the problem here is really 1/2, so the constant of variation here is 1/2. Whatever that constant of variation happens to represent here, there's a relationship of 1/2 going on. It could be that every person in a house generates 1/2 bag of trash. So 1 person generates 1/2 bag of trash. 2 people generate 1 bag of trash. 3 people generate 1.5 bags of trash. Well, every time we reduce that fraction down, all right, the relationship shows 1/2 because everybody generates 1/2 bag of trash. All right, let's do one more together, number 6. This equation's got some problems because this is not slope-intercept form because 8 is in front of this y. So I want to get rid of this 8. Since it says I'm multiplying by 8, I'm going to go ahead and divide across by 8 to cancel that out. Now, when I do that, I'm going to simplify what I have left, and I have y equals what ends up being 1/2, 4/8, x, minus 12 divided by 8, 12 divided by 8. That's going to change into 1.5 or 3/2, whatever you want to write. So the question here, is this direct variation? Well, here, this shows me that this graph is going to go through the y-axis at negative 1.5 or negative 3/2. Can't do that. Remember, all these have to go through at 0 in order to work. They can have any slope they want, but it has to go through the y-axis at 0. This one's going to go through at negative 1.5. So this one here, that's a no. It does not represent direct variation, and since it doesn't represent direct variation, we don't even have to worry about the constant of variation. All right, let's look at the next section, 7 through 12. Tell whether each set of data represents a direct variation, and if so, identify the constant of variation, and then write the direct variation equation here. So what you have to know here is that the constant of variation can always be found by taking y and dividing it by x. That's one of the formulas I gave you today in the instruction. The constant of variation is equivalent to y divided by x. So what you want to do here is identify your y values with your x values and hope that the result is the same every time. If it is the same every time, the value when you take y divided by x is the same in every division, right? That means yes, this is direct variation. And then the constant is going to be that number. If you get something that's different at any one point in time, it's automatically no. The relationship does not hold throughout, so then it's no, it's not direct variation. So take a look at this guy. 2/10. Again, it's always y divided by x. 2 divided by 10 is a fifth. 4/20. Well, if I reduce the fraction 4/20, it's equal to a fifth. 6/30. If I reduce the fraction 6/30, that goes down to a fifth. Since each one of these is equal to a fifth, in this particular instance, the constant of variation here is a fifth. Is this direct variation? Yes, absolutely, since it is a fifth every time. All right, let's look at 8. Start with the 2 and the 5. Remember, I got to do y divided by x, so I'm going to do 5 divided by 2, 2.5. 10 divided by 4, 2.5. 15 divided by 6, 2.5. Since each one of those divides out to 2.5, this is another yes. Constant of variation here, you can write it either way. You can write 2.5, or if you want to write it as 5/2 as a fraction, that would perfectly be acceptable. 5/2, 5 divided by 2 is equivalent to 2.5. All right, let's do one more here. Let's look at number 9. Number 9, we're going to go ahead and start dividing. Now, they didn't give me x and y here, but we can just change these into x and y. It's not a big deal. So I'm going to have x times at bat with y hits. 1 divided by 3, third. 2 divided by 6. Well, 2 6 reduces to a third. 4 divided by 12. Well, 4 divided by 12 reduces to 1/3. So since all of these are a third, this is another yes. Constant of variation here is 1/3. And you'll keep doing the same thing with 10, 11, and 12. Look out for that constant of variation. If it happens to be the same as a yes, then simply identify the number you have there when you divide. If you get one time a different number in the question, it's automatically a no, game over. All right, let's go down to the bottom part here. Tell whether each graph represents a direct variation. If so, identify the constant of variation and then write the direct variation equation. All right, so remember, as we've said many times here, right, the y-intercept in direct variation has to be 0, which means in essence, in order to be direct variation, the graph is going to have to go through the origin. Right? Well, if we take a look at this graph here, number 13 goes through the origin. So to answer if it's direct variation, you write yes. Now, as far as finding the constant of variation, the constant of variation is your change in your y compared to your x. So pick a point. They're going to pick, in this particular problem, this point right here, which is 1, 4. 1 on the x, 4 on the y. To find the constant, I'm going to do it the other way though. Y divided by x, like you just saw. So 4 divided by 1. 4 divided by 1 is 4. So the constant of variation is going to be 4. And you say, well, what if I don't want to do that point? Well, here's some other ones. All right, here's this point up here. All right, 2 on the x, 8 on the y. Well, to find the constant, I'm going to do y divided by x. So 8 divided by 2, 4. Go to this point up here. 3 on the x, 12 on the y. So I do y divided by x, 12 divided by 3. No surprise, 4. Right? So every time we end up with the same constant of variation when we do y divided by x, 4. So the constant of variation in number 13 is 4.